Well, thank you very much indeed for that introduction, Kevin. I feel quite at home here because I started at Cambridge University as an organic chemist and then went to biochemistry, cell biology, and my research was in parasitology, which I won't mention before lunch. I got lost. I was flying commercially, doing precision agriculture with unmanned aircraft in the UK in 2007, spoke to a Canadian at the Farnborough Air Show, and ended up in Medicine Hat. The organisation I work for was incorporated in 2007 as a nationally registered not-for-profit, funded 3/4 by Alberta and a quarter by Western Economic Diversification. In the last year, and Bruce Lutley may be in the audience, he's certainly talking later, from the Grand Prairie Regional College and the Centre for Research and Innovation, we formed a partnership there and established an office up in the Peace region. And Lloyd Shirk is our lead person there. And our purpose is written there. We are the facilitator, we are the change agent, trying to make people aware, as you'll see in a second, of the bottom line business benefits that unmanned systems can now deliver and increasingly will as the regulations enable non-segregated operation. So those are our 6 core programs. So part of what I'm doing now is awareness and a wee bit of education, and I'm fishing, especially with the last speaker, for some cooperation opportunities. Our applied research, as I'll mention later, falls into 2 areas. We do some facilitating applied research in the area of integration standards and in support of the development of standards. Often this is not commercially attractive. The commercially attractive R&D, we have networks and cooperate with them and facilitate, but we're not trying to compete with universities or with private R&D. The technology development, and you'll see our robot outside, his name is Gerald. That's a good example of the technology development, taking an Xbox controller and a commercial product or some other ones and integrating that into a robotic environment with some artificial intelligence. Fadi Khaled, our CTO, is here and can talk to you more about how we do that. And later on, technology demonstration, that's to show to customer communities how we can deliver business benefit. And that's quite challenging. And once we've got a solution, system deployment. These are our core areas of interest, and they are focusing primarily on the resource-based economies of Alberta and the western provinces. They fund us, so that's what we're responding with. Much of what you've heard today falls in these categories. Launch at the bottom is a bit of an exception. We have the only fully civilianized UAV launcher in North America. It's recently been deployed to the Pacific in support of the military, admittedly, made in Finland. But it is a unique Canadian facility. In fact, it also works in the United States for launching unmanned aircraft for development purposes. Up in the Peace region in particular, we've got a proposal underway with the Grand Prairie Regional Emergency Partnership for emergency response. We've already got several police forces across Canada flying with small unmanned aircraft already, and we train policemen for incident response. But it's the event response that's probably more interesting to forestry and agriculture: spills, fires, cut blocks. ACAMP, we partner with ACAMP. We have a project led by ACAMP, that next one down, exploring the application of artificial intelligence at micro and nano levels. And that's one led by ACAMP, and we're a small player along with the University of Alberta in that project. I don't know if the link was made earlier, and I'm grateful to Laura's speech for a couple of reasons, but that composite vehicle, the one made of fibre, there's a company in Calgary called Motive Industries, and Nathan Armstrong there is part of the EVE consortium making an electric vehicle using this composite fibre. Curiously, there's also a project, quite a large international one, for public rapid transport. Now, at the moment, these are little 4 and 6 modules that go along on rails. At Heathrow Airport's got one, for example, and the Middle East, there's another one. But the aim is to take that from rails and put it on public roads as highly granular, highly efficient, fast throughput, low queue time public transport, which I would use. But instead of 10 minutes for 100 people, it's 1 minute for 10 people, that sort of model. So PRT will be, as we go towards energy efficiency and better transportation, better. And Fadi is the person who's going to help try and make this more intelligent. And I won't bore you with standards, but you gathered from my question earlier, this is a major activity. So after 2 years of work, I've got Transport Canada now with a program doing development of unmanned aircraft standards to allow routine, regular flight in airspace. It's possible to do visual line of sight operations now. I hope beyond line of sight from 2015 onwards. But one reason I'm here is that from 2015 onwards, beyond line of sight unmanned aircraft operations, I hope will be a reality. And we are oozing with applications in Alberta, and the former speakers just mentioned that. We also have a project that I'd like all your support for, because we're asking Transport Canada for some segregated airspace down near the village of Foremost. We do have segregated airspace where we can fly unmanned aircraft for defence purposes at Suffield, but the nasty British come there and fire tanks and aircraft and missiles most of the summer, so we can't do that. We have about 100 square miles. So what we're looking for here is not for high-risk use, it's for training people and for application development, putting out dummy pipelines, dummy arrays, flying our sensors against them in the Foremost area. And there's a study underway. I think the RFP closes on Monday, which should lead to a formal bid to Transport Canada for that airspace. But that would be a great Alberta asset. It would be a great Canadian asset. And network development. We do a lot of network development across Canada and internationally, on the search and development, on the regulatory front, application development. I won't bore you with the details, but there are lots of things going on there. And training. And as of yesterday, we were in the University of Alberta, and we're going to be forming an Alberta UAS community of interest, probably based about that very advanced IT tool, Facebook, as a start, but to try and get people involved in the community. And then, parallel to that, Automate will be a more formal collaborative grouping of Alberta stakeholders in the unmanned aircraft sector to start actually doing substantive stuff. Within forestry and agriculture, and I'm aware of the time, in 2007, on my own farm in the UK, we were using unmanned aircraft for precision agriculture, and that's how we started, optimizing the use of fertilizer and that sort of thing. And I won't go through the other ones in detail, but there are a range of applications in these sectors. What about micro and nanotechnology? Well, as you see on the slide, I've made there a small n, because I echo Kevin's comments exactly, that an awful lot of what we do will be more at the micro level than the nano level, because we're actually looking for combinations of functionality miniaturized, and particularly if we're going to put that in aircraft. The smaller, lighter, more efficient we can make the aircraft, the more economically feasible the whole nature of the operation is. And you could imagine swarms. I hate the word swarms, I don't know what it means, but lots and lots of very small, cheap platforms giving you very granular, very time-sensitive information. And on the ground, we might be looking at MEMS. There's quite a lot of work in the defense side as to what MEMS can be used for in the unmanned world for defense purposes. But I think the previous speakers highlighted several applications to do with forestry, rehabilitation, reclamation, where you want good information on the ground, and why send people there if you don't have to? And of course, coupled with that, there's the whole question of, if you do deploy lots and lots of small platforms, can you build intelligent self-configuring networks and couple that with unattended ground centers doing tail pond pollution, river pollution, air quality monitoring on the ground? So an automatic deployed network. And so I think in there, the main opportunities are, when we know exactly what sensor packs and combinations we need, let's shrink wrap those, miniaturize them, and cut the cost. And also at the navigation level. Those are the two most obvious areas, I think, for the application of micro. Our engagement model is, before we can help anybody, we really need to understand the customer requirements. So we're learning fast about some of these different areas. I'm quite good at wheat growing myself because of my farming background and others, but I don't know much about forestry, so we need to get wise there. Having looked at the requirements, we look at what sensors and what options are feasible. We will develop and put those together, or Fadi will lead in that, system assembly with partners, and then with partners, mount a technology demonstration to demonstrate to the customer community that there is benefit in this approach. And if there's not benefit, it's not worth doing. And at that stage, we can revise the requirements, firm them up, and that then becomes a commercial opportunity for for-profit industry to go for. That's my final slide, and I've caught up a lot of time. Automate is the collaborative group we're going to set up, and with automation, the opportunities are infinite. Thank you.